All right, so now that we reviewed how to multiply and divide fractions, let's basically knock it up a notch and do all this with polynomials. Basically, the two big, dare I say F words, there's going to be a lot of factoring. All right, that's going to help us do some simplification. And then, of course, all our fraction work, right? Multiplying it straight across, dividing, we multiply by a reciprocal. Okay, so let's see that in action. So on the very first one, right, we're being asked to multiply. That's what that little dot right there means. So how do we multiply? Just simply straight across. So one numerator to the other numerator, and then another denominator to the other denominator. So that's it. We're being asked to multiply. And then always, right, when we're dealing with fractions, you should make sure it's simplified. And that means that there's no common factors upstairs and downstairs. So upstairs, we have a factor of x plus 5 and x minus 2. And then downstairs, we have a factor of x and x minus 5. So there are no like terms, no like factors, So we're done here. That is it. The only other thing that might be different, the book might vary in how, I'm perfectly fine with this answer. You've done what you're supposed to do. You've considered the simplification. But the book might actually ask you to multiply this out, right? So you'd FOIL that out. I think you get an x squared. Plus 5x minus 2x minus 10. And downstairs, if you distribute, you get x squared minus 5x. So a possible answer that you might be asked to do in the book, right? So just read your directions carefully, is to multiply everything out. But as you guys move forward and you get into 151, keeping things in a factored form actually tells us a lot of information. So that's why for testing for my class, I'm perfectly okay with that answer there. Okay, so after all that, how about B? Well, again, we're being asked to multiply. So again, it's basically the top numerators multiplied together and the denominators multiplied together. All right, and then of course, now that we've performed the fraction idea of multiplication, we now need to make sure we're simplified. So we have factors of x minus 3 and x plus 4. We have a factor of x plus 2, but this guy is the difference of squares. So let me go ahead and rewrite the numerator, rewrite the denominator, but we know that that factors as x minus 3, x plus 3. So we now see that there's a common factor, right, of x minus 3. So those guys will divide each other out, and so we're left with the final answer of x plus 4 up in the numerator, and then x plus 2, x plus 3 down in the denominator. Again, I'm perfectly happy with this answer, but be careful with directions in your textbook. They might ask you to multiply that out. All right, so just read directions carefully. So for letter C, again, we're being asked to multiply. And so we multiply the top to the top and the bottom to the bottom. So there's the multiplication. Next move is we have to make sure that there's no common factors involved, which means we got to factor everything. So x plus 1 is already factored, but this guy we can pull out a GCF, right? If we pull the GCF out, we get x times x minus 2, and then of course we already had an x plus 1. 5x is just a nice term by itself, but that guy, that trinomial, if we do a quick guess and check, I believe we'll end up with x, let's say I think plus 3 and x minus 2. Let's do that. So first times first is first, last times last is last. We get a 3x and a negative 2x. Yeah, so that's the right factorization. So looking at what we have, we can see that there is some common factors, right? X is a common factor. X minus 2 is a common factor. So they'll basically divide out. And so in this case, our final answer, let me write it over here, will be basically x plus 1 up in the numerator, and then 5 times x plus 3 down in the denominator. And again, I'm okay with you leaving it completely factored. Again, the book might want you to distribute that, but we're good. Okay, so you can basically see we're multiplying top to top, bottom to bottom, and then we're factoring, right? And then dividing out common factors. So if you want to, in this next example, what I'm going to do is do it all at once. So again, we're being asked to multiply, and as I multiply top to top and bottom to bottom, I'm going to go ahead and factor. So this trinomial, it's a perfect square trinomial, and ill factor is x plus 1 times x plus 1. Again, or you're guessing and checking, and you can check that. This guy is a difference of squares. So that's x minus 5 and x plus 5. So what I did is, maybe saved myself a step. While I multiplied the numerator to the numerator, I factored as I went along, because we know we're going to want to do that to simplify. And so on the bottom, x plus 5, that does not factor anymore. But x squared minus 1, that's another difference of squares. So that'll factor as x minus 1 and x plus 1. So we've multiplied top to top, bottom to bottom. We've factored. So now is there any common factors? And the answer is yes, right? There's an x plus 1 in common with an x plus 1, right? There's x minus or x plus 5 in common with an x plus 5. So I think that's it. So writing our final answer here, right? I'm going to go ahead and leave it in factored form. All right, we have x plus 1 times x minus 5 in the numerator, all over x minus 1 in the denominator. And so that is our multiplied and simplified final answer. All right, E has a little tricky spot. This is clearly, right, a fraction, and we're multiplying it to just a normal polynomial. But we know, right, everybody can be written over 1. All right, so we basically have, let me write it this way. We have the fraction x plus 2 over 3x plus 2 times the fraction 9x squared minus 4 all over 1. So now this looks a little bit like what we did in A, B, C, and D. All right, and so working with that, what we end up getting, right, again, we'll multiply the top to the top, and I'm going to go ahead and factor as I go. This is the difference of squares. So 3x minus 2, 3x plus 2, all over a 3x plus 2, right? Anything times 1 is just itself, right? So again, kind of like I did in D, as I perform the multiplication, I also factored. That's already factored, that's already factored, that's a difference of squares, and that's just 1. And we clearly see that we do have a common factor, right? 3x plus 2 will divide out. And in this case, right, our denominator, technically speaking, we have x plus 2, 3x minus 2 all over 1. But anything times 1 is just itself. So I'm pretty sure that'll be, that's the answer I want to see on a test. But again, follow the directions in the textbook. They might ask you to multiply that together, which you'll just FOIL. All right, last but not least, again, one more multiplication. And so in this multiplication, what we're going to be doing is multiplying top to top, bottom to bottom, and I'm going to factor as we go. So using my guess and check skills here, I believe that's x minus 2 and x plus 1, right? Yeah. This guy's already factored, right? Can't factor anything out of that. So there's the multiplication of numerator to numerator. And then down below, we have a couple of trinomials of degree 2. So again, I'm a guesser and a checker. So let me see, right? This guy right here, what would be a good combination? I think I'll put the 3 here and the 1 there and the next there. And I believe a plus and a minus will work there, right? We have a 3x and a negative 2x giving me the positive x in the middle there. So I am good to go. And then for the next one, right, for this guy, again, we're multiplying it. Again, I think we have a 2x and an x. We also have a 10, so that's 5 and a 2. I think this is going to work. Put the 5 here, put the 2 there, put the plus sign there and the minus there, right? So there's a 5x and a negative 4x giving us the positive x. So you used my, still kind of get used to my little thing there, okay? So there we have it, all right? So everything's factored, everything's multiplied, and so now we're looking for common terms, common factors. So I'm looking at here, I see a 2x plus 5 and a 2x plus 5. there's an x minus 2 and an x minus 2, and I believe that's it. So our final answer is just x plus 1 in the numerator and 2x plus 3 and x minus 1 in the denominator. So again, the two big guys, right? Our fraction work, in this case multiplication, just top to top, bottom to bottom. Our factoring work to help us simplify and divide out common factors. So that is how you multiply rational expressions, right? In the next video, we'll talk about division. All right, see you soon.